Problem 8. We're given a sequence of numbers defined by the following expression. We're trying to find the partialities, evenness or oddness of the triple numbers of D2021, D2022, and D2023, where E and O denotes even and odd. So to solve this question, we must first find the pattern within this given sequence, and that's typically done by trial and error. The reason why I know this is because just from looking at this, I don't know any sequence where I know which term is even and which term is odd. So I must make some trials and therefore find the pattern. And for these type of questions, you cannot get discouraged. You must make sure you do the algebra correctly, and you must make sure to stay organized. So that's what we're going to do. Let's put D0 here. We're going to call this a term. We're going to call this the value. We're going to call this the even or the odd. So if we were to have this table, we would stay organized while staying on track. D of 0 is given to be 0, D of 1 is given to be 0, and D of 2 is given to be 1. 0 is neither odd or even, but for this case, 0 will be considered even because any term that ends in 0 will be even. And that's just the intuition I have to set this to be equal to even and not odd. So this must be even and this must be odd. Given this, let's continue. What is D of 3? D of 3 must equal to D of 2 plus D of 0 based on the given criteria, right? Because it's 1 less than 3 and 2 less than 3. So, or 3 less than 3. So that means D of 2 plus D of 0 will be giving me 1, which is an odd number. D of 4, I'll make it red, therefore everyone can stay with me when I'm doing the calculations. D of 4, right, D of 4 in this case will be equal to D of 3 plus D of 1. So D of 3 plus D of 1 will be equal to 1, which is also odd. What about D of 5? If D of 5 is here, then D of 5 will be D of 4 plus D of 2, which gives me 1 plus 1 is 2, which is an even number. Now let's consider D of 6. Or let me change color, that will be blue. So D of 6, that's blue, will be equal to D of 5 plus D of 3. So D of 5 plus D of 3 will give me 3, which is an odd number. Now let's change it back to red. What is D of 7? Well, D of 7 will be equal to D of 6 plus D of 4, which gives me 3 plus 1 is 4, which gives me an even number. And now let's consider the D of 8. Let me change it to this light blue, D of 8. So D of 8 will be equal to D of 7 plus D of 5, which gives me 6, which is an even number. Now I want to stop here because I realize there's something going on. I have a double repeated even quantity. Where do I have this in my previous problem? I have it with D of 0 and D of 1. So I might be onto something. I might have solved the pattern. Let's continue to make sure. What is D of 9? D of 9 is D of 8 plus D of 6, which is equal to 9, which is an odd number. What about D of 10? D of 10 is D of 9 plus D of 7. D of 9 plus D of 7 is 13, which is an odd number. Yes, indeed, the correlation is apparent. I'm following the same pattern. So whenever I go from 0 to 6 or 7 terms, I have a repeat in terms of the even and odd quantity. So I have the pattern that I need to solve this question. Because we know if we have a periodicity of 7, everything can be used modular arithmetic to solve and find the correct partiality. So in this case, which quantities are D of 2021, D of 2022 corresponding to? Well, since we have a periodicity of 7, it repeats for every 7 terms. So how many 7s are within 2027? That way we cancel out repeating patterns. Dividing this by 7, we get what? 2, we get 14, 62, we put 8 here, we get 56, and we then get 61. We put 8 here, we get 56, and we get 5. So that means 2021 mod 7 will be giving me 5. Now 5 is just a remainder of this division quantity. And that's important because that means that after repeating the 7-term pattern for 288 times, I'm left with the 5th term, the equivalent of the even and odd value. So now let's consider 2022 mod 7. What is 2022 mod 7? Well, 2022 mod 7, just divide it out. So divide by 7, 2, 14, 62, we put 8 here, 56 becomes 62, we put 8 here, 56 becomes 6. So that means 2022 mod 7 will be equal to 6, which is obvious because 2022 directly follows the 2021 term. So by logic, 2023, without even needing to do the modular, we know that this must be equal to 7, right? And if this is equal to 7, but that can't be right? Because if I were to have a mod of 7, I can't equal 7, so that must mean 2023 must be divisible by 7. Let's make sure that's right. 14, 62, we put an 8, 56 becomes 63, and we put 9. Indeed, the remainder is actually 0. But in this case, the 0 term is the equivalent of the 7th term, because again, we repeat. So on the 7th term, So if you to represent this, you can see here where the seventh term is the equivalent of the zeroth term. You see it with the green. I apologize for the messiness. Here, let me do it in the red. So you see that the zeroth term is the same as the seventh term in terms of the odd and even quantity. So that's why we can put 7 in place of 0, because they're the same thing. So we know that they must be equivalent to the 5, 6, 7 even and odd value. So 5, 6, 7 we have even, odd, even, so they must be even, odd, even. So we must have an answer choice where it's even, odd, even, and sure enough, answer choice C is our final answer.